Okay, hello everyone. Welcome to our weekly OPI API work group meeting. We were kind of light on topics for this week. I think the first thing that we want to go over was a request to discuss the EVPN gateway PR. So I think Demetrius, did you have something that you wanted to bring up on that?
Yeah, I mean, last week we have talked in this meeting. We have discussed in this meeting that we will give 1 week for review of the PR to see if any comments are coming up. Vipin has pasted some comments there. I have addressed those, and I don't think there is anything left there. So the PR is ready for merging, but I understand that Boris wants to actually have some reference implementation in the EVPN gateway bridge in order to merge the PR. This can happen, but it will take time because of internal issues that we need to lift. We cannot just push code to public repositories right now. We need to take care of internal things in corporate things. So this will take time. So this is the way that this thing works. So we will not be able for now, at least for this week and next week probably, to push any code to the VPN gateway bridge. So
Okay, so let's discuss that in the group here. As a group, do we feel that we need to have a prerequisite for code pushes like this or API changes like this to have a reference implementation, or do we need to put the APIs out there, then build the reference implementations and make any changes as we move forward? Is there any view from the rest of the group on that?
Well, Mark, I think we had similar discussion earlier on the cloud APIs. As long as there is an intent to build reference implementation, we should go ahead and start to float the APIs so we can get more comments. And as we build reference implementation, we define those APIs.
Okay. I mean, my feeling is the same. I want to make sure that we get a consensus on this. Because I want to put this down as some of the guidelines for the check-ins so that we don't run into, delays related to getting things into the repository. So any other comments related to that?
Yeah, I would say let's not delay putting it in the repo. I think it's harder to discuss and to collaborate on if it's stuck in a PR. And I think we can, if we should contribute it, and then if we want to make changes to it, then we make changes to it. But I think that holding it in outside makes it really hard to collaborate on.
Okay, all right. I will.
I mean, just to add to that, I mean, this is the base API right now, and
Right.
I need this in order to actually start implement. Actually, right now I'm implementing a CNI for the which I'm calling XPU CNI. I believe it's accessible for everybody, but right now it's just initial code, and I will just exercise that API because the CNI will be a client to that API, right? In order to create bridge ports and stuff. So we have big intents to actually push code that actually exercises this API from gRPC perspective, VPN gateway bridge perspective, and CNI perspective. So yeah, that's the status.
Okay, all right. I'll work with Boris on trying to get him to click the approval button. I think once we get, and I'm checking it right now, there's a couple. I want to make sure we have all the approvals that we need to get it merged. I think according to the PR, which I just pulled up, we have, where is it? All right, it's a long way now. We have 2 pending reviewers. I think Vipin, I think if you will, I noticed that you put it in there already that it looked good to you, but I think you have to do the approval on it.
Okay.
And
okay,
then
I'll do that.
and I'll get with Boris about getting him to get that done. Hopefully we can get this over the hurdle and we'll get it merged in. All right. And I'll also put together some published notes related to how we want this to move forward in the future so that we have the guidelines in place and we don't hit any more delays related to getting things merged in. Okay, with that, the other topic that I had put on the agenda, and I don't know if we're ready to discuss it yet, was related to the transaction support. I don't know if that's ready to be discussed or not. It doesn't look like it, so. Other item this week was transaction support. But I'll post that one for next week also. Are there any other topics that the group wants to discuss this week? Yeah, Donald?
Hi, so we've been working in the background on the proposal for extending kind of hardware offloads from the Linux kernel. We've got some slides, so if it's a short agenda, we could go with that today.
Yeah, it's a short agenda today. I didn't get any feedback on other topics, so yeah, please go ahead.
Sure, okay. Let me just get ready to share. Too much on my screen, sorry. Nearly there. Bear with me, I'm just trying to get into slideshow mode. Yeah, so can everybody see my slides? Just
Yeah,
want
looks
to
good.
check that
Yes,
shape.
they're up.
Yeah. So the background here is, as I've mentioned on previous calls, is we're trying to find ways to enable offloads to DPUs that essentially work in concert with the Linux kernel, kind of sitting behind the interface that the Linux kernel presents to user space, so that user space applications can proceed unimpacted and achieve some kind of benefits of the DPU being there without needing to be rewritten specially to make use of DPU features. So the kind of umbrella, one of the projects we're exploring here, we're calling extending kernel hardware offload. And there's a couple of things within that that are the approach that we want to prototype and see if that will give us a way forward for what we're describing here. So the very quick elevator pitch here, what are we talking about? We're talking about, as we say, extending hardware offload API of the Linux kernel in some way without necessarily involving a huge amount of kernel feature development. Why do we want to do this? Well, it would be very desirable to decouple hardware offload enablement from driver development, because I think it's driver development that slows the process down significantly and puts a lot of vendors off adding significant features into the kernel-enabled driver path. And also, the kernel's complicated. It's grown over the years, and there are quite a few different hardware hooks, hooks within the kernel for hardware offloading. And there's really quite a few there that make it very, very complicated for vendors to integrate with. And also, it's a fixed, at any point in time, it's a fixed API. The offload capabilities that are offered by the kernel to drivers is a fixed API, and if you want to extend it, then it's more upstream development and looking for the features you're proposing to be accepted by the broader kernel community before you can move forward with them. So I think there's a number of barriers to innovative hardware offloads, and that's really the why of why we want to explore this. So how do we hope to explore this? Well, there's a couple of things, couple of approaches. The first, I think we've mentioned on previous calls kind of briefly, and we've talked about as a mechanism for for understanding the configured state of the Linux kernel, and that's to use a NetLink listener to enable offloads entirely in user space. So listening from user space to all NetLink notifications of the correct NetLink families and mirroring that information over to some kind of hardware programming path that, being in user space, could make use of vendor libraries. And the second part of this is where there is kernel state that cannot be discovered by NetLink listeners, that we could look at extending the offload capabilities using BPF programs within the kernel. So there's a couple of ways this could happen. One is we introduce new specific types of BPF program hooks, which hook into the kernel triggered offload path and actually explicitly call BPF programs as part of the offload enablement. So that's upstream development, a kind of one-time upstream development to create the infrastructure necessary to be able to add BPF programs that explicitly want to send the offload requests up to user space through BPF ring buff notifications, and allow a user space application to do the bulk of the work of doing the DPU hardware offload. And the other approach might involve just using BPF programs registered at existing BPF program hooks or trace points or K-probes to listen for things that don't have explicit BPF program support, which gives you a way forward without necessarily needing to upstream things, but has the risk of being exposed more to kernel internal changes. And finally, the real desire is to see if we can enable new types of offload beyond the set of offload capabilities that are currently supported or are supported by any given kernel version, such that vendors and consumers would be able to truly be innovative in saying, well, there's something that I can program in the DPU, and I want to enable getting notified of some piece of kernel state or user application state that would enable me to switch on that offload capability without needing to do any kernel development at all. The BPF programs gives a potential for decoupling the development and deployment of the glue that would attach DPU capabilities to kernel features without needing to do kernel development. It gives you a nice separation of what the vendor can deliver from what necessarily has to be upstreamed and delivered in new kernel releases. So just going briefly over the traditional offload APIs, from application space, pretty much all of the user space applications use NetLink to program the Linux kernel. And so that's the common feature across all of the Linux kernel networking stack, is programming is done via NetLink. And then within that, there is all the different subsystems, switch dev, net filter, routing, etc., etc. And all of them have various types of APIs with the network drivers, going through NetDev, going through switch dev, going through various other mechanisms. Take, for example, TC-Flower. TC-Flower uses a NetDev hook called NDO setup TC, which takes a number of parameters and basically squeezes all of the hardware offload signaling to the driver through that single dispatch API. But it's a fixed enumeration of things that can be offloaded, and it's within the scope of the TC-Flower feature set. So if you wanted to extend that mechanism for hardware offload, you'd be developing new TC-Flower features or developing a new type of TC filtering mechanism, and then working out how to dispatch that down through the setup TC dispatcher through our driver. So that's quite high cost in terms of new feature development, and it's also quite complex in terms of integrating capabilities into your driver to actually offload to hardware. So one possibility is that we move some of that hook into something that you could program in BPF, which entirely decouples it from kernel development lifecycle, but still it doesn't reduce the complexity of how to implement that offload. The other mechanisms are things like kernel notifiers for switch dev, which is how Mac and VLAN learning and Mac and VLAN offload get done through switch dev devices. There's also the equivalent for FID entries for doing route offloads, etc., etc. So there's a variety of notifiers. That's really the point. But the common reference point for all of them from a configuration perspective is network. The issue is that when things are learned from the network or things are generated internally, such as generated IPv6 link addresses, some of those things might not be that easily accessible through Netlink, or might not be automatically notified through Netlink. So we want to make sure that there's ways to get at those things that don't 100% rely on using Netlink from user space. Okay, so for our POC, what we're planning to look at, there's a number of aspects to it. The first, as I've kind of alluded to, is to mirror the kernel networking state to user space just using the Netlink listener. So that's kind of the baseline. That covers the majority of what we'd need to know in terms of configuration and state of the Linux networking stack, such that you could push to DPU tables enough information to be able to enable offloads that are maybe you've got a P4 pipeline programmed on the DPU, and there's sets of tables that are there for doing route offload and VLAN offload, encapsulation offloads, etc. So you can learn all of that state from Netlink and program those tables from a user space application. The next is to use BPF to enable to provide a notification path for things that are not visible through Netlink. And ultimately, once the programs are there at the kernel hooks, and be able to either write into BPF maps or just directly notify via a ring buff to user space, then you've got another notification path alongside the Netlink notification path that goes direct to user space, and then the same mechanism from user space can be used for programming down to the DPU. The next two things are using BPF to extend the offload functionality of kernel drivers. So in other words, essentially writing some of the kernel driver firmware in BPF, if you will. So maybe the driver's still responsible for programming the DPU hardware rather than user space, but it's there's some BPF glue in there that binds what the kernel's asking for in terms of an offload to how it then gets done for the driver. And the final thing is the looking at new types of offload which are beyond the current kernel scope, and that's where you're enabling innovation beyond having to push new features into the kernel, so you can rapidly take advantage of maybe something that you've figured out how to do in a P4 pipeline that you want to be able to enable, and you'd use new hooks, your own BPF hooks in the kernel to pass whatever states needed to trigger and enable those offload features. So that's the kind of four aspects to the POC that we want to look at.
Hey, Donald, Vipin's got a question.
Sure, go ahead.
Yeah, I wasn't sure if we could ask questions during the presentation or towards the end, but anyway, when you say mirroring the kernel state, network state, kernel network state, I mean, it's quite a lot, especially if you want to do something stateful, like what Contract is doing and all that. So can you define what do you mean by a kernel network state? Because otherwise we'll end up pretty much replicating everything. I mean, it's a lot of work, but also it's inefficient if we were to go to that level.
Well, essentially, if you need visibility, if you need the same equivalent capability as the kernel has in its internal state, then you are talking about everything, yes. If you are only interested in a subset of that, such as forwarding or bridging or something like that, then the scope reduces. And then for any given use case, you can obviously be more selective, but in the broadest sense, yes, everything in the in the networking layer is right for being mirrored across to DPU tables if you want the DPU to be able to accelerate them. And that's what the driver would have to do in the traditional path, is essentially be notified of everything that is being programmed in the kernel networking stack and push it down to the hardware if it's wanting the hardware to be able to accelerate it. So in terms of scope, I don't think it's really any different.
Okay. Okay, because we talk about this firewall use case quite often, and as a very fundamental base use case that all of us want to go after, and this is stateful firewall. So that comes down to tracking TCP, sequence numbers and all that. So in that case, wouldn't it be too much to keep shuttling all that information back and forth?
I mean, it's interesting, isn't it? Because if you're actually offloading the firewalling and you're offloading the connection tracking, then the volume of real-time information drops away again because the kernel becomes blind to what's offloaded, typically. And so really what you then be needing to do is enable just the statistics and notification path back to the kernel so the user sees the stats of everything that's fully offloaded. But you raise a good point in that there is a lot of dynamic state that changes very rapidly. So there are a bunch of use cases that if they're split between the kernel doing half the work and the hardware doing half the work are going to be likely to be degenerate cases. And I think that's true of any solution to this offloading problem.
Yeah, I think you're touching up on a very, very critical point that is near and dear to me, especially, which is that offloading. So the moment you use the term offloading, there will always be this kind of tango that is needed between the two, because there is one place that is maintaining things and there's another place that's accelerating it. Whereas, if you are doing all this functionality in the DPU itself, when I say DPU is in DPU data path or DPU fast path, then there is only one owner. So, I mean, we could discuss more on the possible alternatives to do what you're suggesting. And I'm definitely aware of the P4TC work. That seems quite, natural way for me to take entire data path into one ownership rather than do the split, functionality of offloading it. But anyway, I didn't mean to digress this discussion. Maybe we should have it after you're done with your presentation.
Yeah, it's an interesting point, and I think it is worth a separate discussion that should maybe be tabled at some point, which is if you were to take the kernel development team, or sorry, the networking maintainers view of P4TC is, well, we already have a subsystem in the kernel called BPF. So we'd want you to take P4TC and do it in user space and program BPF to do what you want. And I think the proposal here actually complements that viewpoint. And I think that would be a useful separate discussion to have. Let's not derail this until we have some of the outcomes of what this POC might show.
And there's one other question. I sent the question.
Sure.
Yeah, was the same. Like all this was talking about mirroring kernel state into DPU, but how about getting DPU state back into kernel?
Yeah, the equivalent reverse path needs to be enabled, and I don't have a good diagram for that in the slides, but you can imagine user space writing back to BPF maps and BPF program hooks at, for example, fetch stats hooks or something like that, or kfunc helpers being able to be called by BPF programs. So there is a way back and for the reverse path, and we need to drill into that a bit more, but that's not in this set of POC slides.
Okay.
So sorry, I've lost. Here we go. So yeah, just a quick view of from outside the kernel, from user space, if we want to just simplistically mirror networking state, then we just need a user space listener to netlink notify messages registered on all the relevant netlink families. And that listener can make use of user space libraries, vendor libraries, whatever, to do out-of-band programming to the NIC. Now, there's a dotted line here, just kind of glossing over how that actually happens. It may well still be needing to speak to the networking driver to enable that to happen, or there may be much like DPDK, there might already be a channel opened to the NIC in order for the vendor library to be pushing configuration down. We're glossing over that in the diagram here, but basically we're wanting to show what the interaction from the user space application is with the Linux kernel in order to enable this path. And then just a couple of diagrams on extending offloads. So from a TC example perspective, you could imagine BPF program hooked into the NDO setup TC path, which is how the TC subsystem asks the driver to offload a specific QDISC or filter or something down to the NIC. And the BPF program could essentially either raise it directly in a ring buff or push the information into a map and notify user space via ring buff that there is an offload requested, and the user space application can program out of band. And it's also possible that with the right kfuncs or whatever, the BPF program could program directly without it needing to go to user space. But that would assume that the capabilities are there for the BPF program to do it via a driver and not need user space vendor libraries to do it. And then the other example here is hooking into switch dev notifiers, where there's some bidirectional notification and learning happening. So the Linux bridge is learning from drivers about MAC addresses and VLANs, and the bridge is in turn asking drivers to offload to device, and we can hook into that notification mechanism, and again notify user space that there is learning and there is offloads being requested that can be pushed down to the NIC by some out-of-band mechanism as well. So these are the kind of scenarios that we're aiming to address and tackle in this POC work that we're planning to run in the next quarter. That's it. Thank you. So if there's any other questions, please fire away. Otherwise, I'll leave you with the elevator pitch.
Can you go back to Donald? Can you go back to the picture that you had where? Yeah, this is good enough. The maps that are produced by the BPF program, are those also read by the user space? Like you have a dotted arrow going up there, or is it just the state that you want to,
Yeah, so there's two things that those maps could be used for. I think you've just alluded to both. One is that the BPF programs can maintain state of the offloads that they have essentially set up. And they could also be a means of user space reading those maps so that you don't need to push all of the information of the offload into ring buff messages. So there's two ways it could be tackled. And honestly, I'm not sure if the performance merits without actually us building a proof of concept here.
Okay, got it. Thanks.
Yeah, the dotted line was just to show that it doesn't have to go, the data doesn't have to go via the maps. It's kind of optional.
Got it. Thanks.
Cool. Okay, thank you.
Hey, one of the things, right? So we have seen this kind of netlink listeners and then programming the hardware, right? It's there in Sonic and even in SwitchDev case and Mellanox or Cumulus, right? So everybody has this netlink listeners and to program to offload to switch, not in the DPU case. But the major hurdle we have seen, at least in our experiences, all the notification from Netlink, it's kind of unordered and it comes in bulk. You have to write additional control plane logics in order to make sure those Netlink messages, you have to maintain a complete state. That's what we have finally done. Most of the open source code, if you have seen, it's just not the listener and then programming. It's not that simple. That might work for basic cases, but once you start scaling and then a lot of scenarios are going on, your interface going up and down and all those things. So all those notification will change. You won't get notification from Netlink in some of the cases. You have to parse that in order to clear ARP cache, for an example, right? So all those cases has to be handled. It's not that straightforward. Just having a Netlink listener and then just programming to offload. Maybe in the DPU case, it's not that complicated. In the server, you don't have that many entries, maybe. But the additional cases also needs to be handled, just for your information. Since you have gone through this exercise earlier, so I just wanted to bring it to your notice.
Yeah, it's a good point, and I think that's why we're kind of recognizing that there's probably either gaps, bugs, and like you're pointing out, limitations to purely relying on Netlink notifications, which is why we're looking to augment that with hooking into the internal kernel notifier mechanism, because there's a number of things that you get a cleaner view of state changes in the internal kernel notifiers. And I think the switch dev notifier API is a good example of that.
Okay.
And there's also, scope for a number of bugs, which could derail this kind of approach.
I have a follow-up question from the use case point of view. Since this is tightly coupled with the kernel, in the use case where you want to manage everything from the DPU, as in you are not trusting the host kernel, are we assuming that this kernel that we are talking about, the Linux kernel, is really running on the DPU ARM cores, which is then using the offloads to the data path of the DPU?
Yes, that's kind of the mental model I have. Yes.
Okay, because I mean, certainly yes, we could go that route, but in that case, usually what I've seen is you can achieve much better since you are having a kernel that is just interpreting the TCP traffic from the tenants which are running on the host. Realistically, you don't need to intercept everything in Linux kernel which is coming from the workload. You can pretty much process everything in the data path directly. By that I mean, for example, I'm going to be a little bit biased here on my point of view because that's what I've seen working, which is P4 based data path. And in that case, P4 based data path could easily handle most of the things, including all the networking functions that we are talking about for various services in the data path itself. So the question I have is, in that case, why intercept everything in the kernel at all if we don't have to, and handle everything in the data path? Because ultimately the promise is that it's going to be 5x or 10x better than what you would get otherwise, and that could only be done if there is no context switch. Now here we are talking about 3 levels of state maintenance and context switches going on for triggering the offload, one in user space, one in kernel, one in the actual data path of the DPU.
Yeah, so I think it's likely to be a hybrid of the two. Speaking to a couple of the vendors, they're kind of assuming that they're not going to go to the effort of implementing routing protocol updates and things like that in the DPU pipelines and ARP resolution and things like that. So if that can be handled by the kernel and that the forwarding table state be maintained in the kernel and just the fib entries pushed to the DPU, then for all data plane traffic, for all workload traffic, it may be entirely within the DPU, but the kernel code is responsible for maintaining the control plane state. Which I think goes some way to what you're describing, which is you don't really want the kernel having to be involved in orchestrating the workload traffic.
Yeah, I mean, no, I think I understand that sentiment. What you're describing is like if someone doesn't want to implement routing information base or what Linux kernel already provides from the routing stack point of view, and they want to leverage it, they could. But at the same time, I feel that it might sound enticing. First of all, I think that is a great use case where hosts workloads need to be involved in this. For example, if Linux kernel and the host is accelerating these things in the DPUs, I totally get that use case. But if you are having an independent Linux kernel just to be able to do that, there are better ways to run open source software that could be programming those devices. But that's my opinion, of course. But yeah, I think I hear you. At least the leverage of trying to use Linux kernel from the networking stack is the goal here.
Yeah.
And there is portability to what you're proposing. I mean, you can run this on a general purpose server, which is not having DPUs, to switch it over to something that has fancier stuff to then take advantage of that, maybe.
Yeah. Yes, agreed.
And also, Donald, I mean, wasn't it the other point of trying to go down this route is not having to go through and change existing CNIs that may not have certain calls in. So if they're setting up something in the kernel, we can then mirror it in the accelerated DPU without having to go and rewrite the CNI to do a whole bunch of other stuff to provision the DPU directly. To know about there's a P4 pipeline under the covers under it.
Yes, agreed. If all of the user space applications are either directly or indirectly using Netlink to program the networking stack, and to introduce a new user space API and expect enough user space applications to adopt that API for the API to be meaningful in terms of programming DPUs, I think is what we're trying to avoid, because that's a huge amount of churn for a lot of separate user space applications, and CNIs are just one of many. Okay, thank you.
All right. Questions, any other time over today?
Mark, just one follow-up on the storage backend APIs. If
Sure.
you can touch Ben to put his proposal that we had discussions on, if you can get that going, that'll be great.
Team on the call.
Yeah, I didn't
Well,
see-
we'll have to reach out to him on Slack to see where we can get with that. I know it's holding up some of the things that you're waiting on.
yeah, thanks.
Okay. Well, all right, everyone. Well, we will. If you got any topics for next week, please go ahead and send them, and we'll work through some of the issues that we talked about earlier in the meeting. Thanks,
Can
everyone.
we make these PowerPoints available that has just been presented by Red Hat?
Good, Donald, can you make the PowerPoints available?
Sorry, I was on mute there. Yes, of course, I'll post them into a pull request into the repo.
Okay, great. Thank you.
Thank you.
All right, everyone. Have a great weekend. We'll meet again next week. Thanks for joining.
Thank you.
Thank you.
Right.